Okay, so this is section 1.4 now. We're dealing with linear functions and slope in particular. So it's still talking about equations, or talking about equations of lines basically. So linear functions and slope. So we begin with the slope of a line, which is basically just the tilt. Okay, so slope of line, and we can define the tilt of a line. So maybe we should notice, what the slope measures. And there's four basic kind of tilts. There's this positive tilt. Oops, there's a hole in my table here. This is when you'll have a slope, which we give the letter m. That's the slope is greater than 0. Then we'll have a negative tilt. Okay, so it's going down, and in this case we say the slope is less than 0. And then we'll have no tilt. So in that case we'll say the slope is equal to 0. And then undefined. When the line is going straight up and down, we say the slope is undefined. So we want to make the measurement very exact, so we can note the difference between maybe a line which has this positive tilt and then a line which is maybe a little less of a tilt. It's a little more horizontal, like this guy here. So what we do is, given any 2 points on the line, so given any 2 points, and we'll just make them arbitrary points in the plane. So we'll say x1, y1, and x sub 2, y sub 2. So given any 2 points in the plane, we can define the slope for this particular line. So we can draw it. Here's x1, here's x2, and then we have the corresponding y1, the corresponding y2. So you have some sort of line going through those 2 points. We'll say the slope, or define the slope to be, and we're using the letter m, it's the change in y all over the change in x, which you probably know better as rise over run. And we're going to get a number for this, so a measurement of it using these coordinates. So y2 minus y1 all over x2 minus x1. Okay, so let's look at some of the ones in the book. This is problem 4. We have 2 points, -1, 3, and then 2, 4. In general, I don't really have this formula memorized. I'm just thinking it's y2 minus y1, so I draw little arrows to remind myself. You just have to make sure you do it the same way every time. You can mess this up, okay? So if you accidentally do it in a wrong order, so you do y1 minus y2 and then x2 minus x1, you won't get the right answer. You can go y1 minus y2 all over x1 minus x2 and get the right answer, but it's best just to pick a method and go with it and do the same thing every time, because there is a possibility of screwing it up if you're not careful. Right? So anyways, 4 minus 3 all over 2 minus, and you got to be very careful with your signs here. 4 minus 3 is 1. Minus minus is a positive, so I have 1 over 2 plus 1, which is 1 over 3. Okay, in terms of these pictures up here, then this guy has a positive slope, so it's rising. And generally when we draw it, we're going to say we go up 1 and then right 3. Okay, so the top is telling you the up and down, and this is telling you right or left. Okay, let's try another one, number 8. So we have 6, -4, and then 4 comma negative 2. So again, I'm just going to sort of use arrows to remind myself how it works. So I'm going negative 2 minus negative 4 all over 4 minus 6. 4 minus 6. So we got negative 2 plus 4 all over 4 minus 6 is negative 2. Negative 2 plus 4 is 2 all over negative 2. And that's just negative 1 over 1. So you think of it with the negative, you're usually going to think of it in the numerator. So you're thinking down 1 and then right 1. So we're always moving in this direction once we get to plotting these slopes. You know, in the book, they're not going to write it as a fraction. They'll just write negative 1 for your slope, and the line is then falling. Okay, so the next section is on point slope form. So we're talking about equations of a line, and you'll want to have this formula memorized. So point slope form of equation of line and so if you have a slope and a point, and we'll call it a point x1 comma y1, you can form the equation of that line, that particular line that has that slope, and it goes through that point. And it has elements of the slope formula in it, and some people claim, you know, if you can remember the slope formula, you can remember this. Honestly, I just have it sort of rote memorized. I use it enough that I have it embedded and coded into my brain. The book is going to give you a lot of sort of puzzle questions. You know, here's a slope, here's a point. Can you give me the equation of a line? And this is a common theme all through math. Even in when you start adding in dimensions, they'll still have the same kind of questions. Given sort of the tilt of the plane and a point in space, can you create the equation of a plane? It's the same kind of baloney. So we want to get, you know, if you're going to continue in math, you want to sort of get familiar with these kind of questions. Here we have a slope and a point. We need the formula for the line. Usually we want to solve for y in this equation for our final formula, but the book will tell you what to do. So anyways, this is x1, this is y1, and I'll have y minus x1, or y1, so it's really easy to screw up, equals 4 times x minus x1, which is 1. Okay. And then we want to solve, we want to get that y variable all by itself. So we want to get this guy by itself. So first I'm going to simplify. So I have y minus 3 is 4x minus 4. Then I'm going to add the 3 to the other side. So y equals 4x minus 1. And this form is nicer because you can read off the slope. The slope is right here. And then this will end up being our y-intercept. So it'll be really easy to plot if we use that form. Okay, let's try another. So this is 18. They give you a slope, negative 2, and then they give you a point, 0, negative 3. Okay. So we'll have y minus negative 3 equals the slope, negative 2, times x minus 0. Okay, simplify this stuff, so you'll have y plus 3 equals, I'm going to distribute the negative 2, so negative 2 times x is negative 2x. Negative 2 times 0 is just 0. So I'm just left with that. Subtract the 3 from both sides. I get negative 2x minus 3. Okay. Let's try one that has fractions in it. Slope is negative 1, and we have negative 1/2, negative 2 for our point. I kind of want you to avoid decimals because sometimes when you use decimals you have to introduce approximations. If you're introducing approximations, they get worse and worse as your work goes on. It's like passing on a rumor. You know, it's the rumor just accumulates misinformation as it rolls down the hill. It's the same thing with approximations. So please avoid decimals. Just use the fractions. Okay. Okay, so we have y minus y1 is negative 2 equals the slope times x minus our x1, which is negative 1/2. Clean it up, so you have y plus 2 is negative 1 times x plus 1/2. And then finally, well, not finally, but we're going to distribute the negative 1. So I have y plus 2 is negative x minus 1/2. Subtract 2 to the other side, so y equals negative x minus 1/2 minus 2. Right? 2 as a fraction, you think of it as just 2 over 1, right? And then you need a common denominator for these guys, so multiply top and bottom by 2. Okay, so you'll have y equals negative x minus 1/2 minus 4/2. And then finally we can combine like terms, and we have our you know, what we're going to call slope-intercept form equation, and we're good. Right? All right, one more. I think it's one more. Let's see. We got a couple more. So the fun continues. We have the negative 2, 0, and then 0, 2. So this time it's a little bit different. You have to do some thinking, right? For the point slope form, I need a point and a slope. So here I have 2 points. So I have more than what I need. How am I going to get the slope is always the question. Well, the slope, you just take the definition of slope to produce that. So it's 2 minus 0 all over 0 minus negative 2. And what do we have? 2 all over negative 2 is 2, and that'll equal just plain old 1. So pop everything into your formula. We'll have y. You could use either point. I like to avoid negatives, so I'm just going to take this point here. So it's y minus 2 equals 1 times x minus 0. Okay. And then y minus 2 equals x. And then add the 2 to the other side. So y equals x plus 2, and that should do it for that problem. Let's look at another one. So number 32, tons of examples for you. Negative 3, 6, and then 3, negative 2. Again, it's the same kind of problem. We're left without a slope at first, so we need to formulate the slope. So I got 6 minus negative 2 all over 3 minus negative 3. 6 minus negative 2 is the same as 6 plus 2. 3 minus negative 3 is the same as 3 plus 3. 6 plus 2 is 8. 3 plus 3 is 6. Simplify, so divide top and bottom by 2. And we're ending up with 4/3 as the slope. So, you know, too bad you have a fraction, but here again, I want you to not convert it to decimal form. Let's go to our point slope formula. So use either point. I'll go ahead and use negative 3, 6. So y minus 6 equals 4/3 times x minus negative 3. You want to clean it up, so y minus 6 is 4/3 times x plus 3. And then we want to distribute the 4/3. So y minus 6 equals 4/3 x plus 4/3 times 3. 3 is the same as 3 over 1, so we can write it like that. So y minus 6 is 4/3 x, and then plus the 3's will cancel, and you'll just have 4 over 1, which is 4. Then finally add the 6 to the other side, and get y equals 4/3 x plus 10. Seems like I made a mistake somewhere. Maybe I made it in my notes. Let's see what I did. Oh, I made it way up here, so sorry about that. So I'll have to try that again. Right, so I screwed up the slope. The slope, yeah, it's negative 2 minus 6 all over 3 minus negative 3. So negative 2 minus 6 is negative 8. 3 minus negative 3 is 3 plus 3, which is 6. So it's actually negative 4/3. So there should have been a negative in front of there. I apologize. Let's go ahead and figure out our equation again. So we have y minus y1, which is 6, equals negative 4/3 times x minus negative 3. So we'll have y minus 6 equals negative 4/3 times x plus 3. Okay. And you have y minus 6 equals, distribute negative 4/3 x, and then minus 12/3 should be just 4. And then finally add the 6 to the other side. So y is negative 4/3 x plus 2 at the end of the day. So again, sorry about that. A lot of room for error in these problems. Okay, let's look at 36. So this is another variation on this theme of let's give the student some information and see if they can handle getting the equation of a line. So we have 1, negative 3, and they're telling you the x-intercept is negative 1. Okay, so the x-intercept is a place where the graph hits the x-axis. So this is our x-axis. It's hitting right here. Okay, so what is that point? Well, that point must be negative 1, 0. In other words, we have 2 points given to us, and it becomes a problem just like number 32. So let me rewrite this so I can do my little arrow thing. It's 0 minus negative 3 for the slope in the numerator, all over negative 1 minus 1. 0 minus negative 3 is 3. Negative 1 minus 1 is negative 2. We'll rewrite that as negative 3 halves. Okay. And then I'm going to use the second point because of the 0 it has in the second position. It'll make my life easier. So y minus that 0 will just end up being y. Okay. And then that equals negative 3 halves times x minus negative 1. So you'll have y equals negative 3 halves times x plus 1. Hopefully that's paper isn't getting in the way. And go ahead and distribute the negative 3 halves. So you get y equals negative 3 halves x. And then negative times positive 1, negative 3 halves. Okay, so we've got a bunch of examples for you there. This last form then, as I think I noted earlier, it's called slope-intercept form, and that's what we want to look at next. Okay, so section 3, slope-intercept. Form, and the title of the form tells you a lot about the form. It has a slope in it and it has the intercept in it. So this is our form y equals mx plus b. M is the slope, so whatever the heck is sitting in front of x is the slope, and then b is going to be your y-intercept. Okay. And let's take a look. So part A, we're talking about graphing these things. And what you're going to do is first plot the y-intercept. And that'll be at the point 0, b. And then secondly, you're going to use the slope to get your second point. So starting at that y-intercept, use the slope to move to your second point. Okay, and then finally connect your dots. All right. So let's take a look at a couple of these. We have 42 from the book. F of x equals negative 3x plus 2. The slope, again, whatever's in front of your x, in this case is negative 3. When we use it, we're going to think of it as a fraction. So I'm going to always put the negative in the numerator. Okay, so negative 3 is the same as negative 3 over 1. This means go down 3 and then right 1. So you're always moving to the right, but the numerator will tell you whether you're going up or down. Okay, the Y-intercept then is at 0, 2. Okay, and again, we get that from this information. And this is our starting point. This is where, when we go the graph, this is where we start. Okay, so let's go over to the XY plane and get this started. Okay, so I'm going to put 1, 2, 3, maybe 4 tick marks on each arm. And I'm starting at 0, 2, so 0, 1, 2 is right here. And then I'm going down 3, 1, 2, 3, and then right 1. Right, and connect the dots and you got it. Okay, so not so bad. Let's look at 48. So we have g of x equals negative 1/3 x. So it's a little different. The slope here, negative 1/3. And again, I always think of that negative as being in the numerator. And so that tells me go down 1 and then right 3. The starting point here is maybe a little hard to imagine, but maybe some of you know it's 0. Okay, if you don't see it, you can rewrite it as plus 0 like that and say, oh, hey, that's the intercept. So the intercept is at 0, 0. And again, that'll be our starting place. Okay. So put a couple tick marks on there. Okay. And then I go down 1, right 3. So start at 0, 0, go down 1, and then 1, 2, 3, to the right 3. Okay, that's it. Okay. You also want to deal with horizontal vertical lines, and these are unusual in that the equations aren't going to have the nice slope intercept or point slope looking form to them, okay? And that can be a little bit confusing. So horizontal, vertical lines. For horizontal lines, what you're just going to see is something of the form y equals, we'll say b. All right, so it has just a very simple form to it. In part B, the vertical lines, the form will be x equals some variable, we'll say a. So let's look at graphing these things. Here's number 50. We want to be able to graph y equals 4. So one way you can think of it, and there's plenty of ways out there, but one way I think of it is saying that y is set to be 4, but x can be anything it wants to be. So you can make up any value you want for x, 0, 2, but whatever those are, x, the y output always has to be 4. Okay, and then you can go and graph the thing. Okay, so 0, 4 is here, 1, 2, 4 is here, and then you connect your dots and you see, oh, I have a horizontal line. Let's look at the vertical case. So here's 57. And the book will try to confuse you a little by writing it a bit differently. So you have 3x minus 18 is 0. You solve for x, so 3x equals 18, and then x equals 6. Okay. Again, you could do a t-table, and what this says is that x is always 6, and y is allowed to be anything it wants to be. So let's say 0 and then 3. Okay. All right, come over here to the xy plane. Need some more tick marks, right? X is 6, so 1, 2, 3, 4, 5, 6, and then y is 0, and then x is 6, and y is 3. And you connect the dots, and you say, oh, that's a vertical line. Okay, the last form we deal with then is the general form of the equation of a line. So, section 5 in my notes, general form. It'll look like this: ax plus by plus c equals 0. Okay. And for these, when you graph them, you're probably going to either convert it into the slope-intercept form, or you want to get the x and y intercepts. So let me write that out first. Graphing these things, there's two ways. So convert to y equals mx plus b form. And we'll give you an example, number 61. So it's given as 2x plus 3y minus 18 is 0. And to convert it, all you have to do is solve for y. All right, so we'll move the 2x and the 18 over. 3y is negative 2x plus 18. Divide both sides by 3. So y is negative 2/3 x plus 6. So I literally just divided everything by 3. 3 divided by 3 is 1. Negative 2 divided by 3 is negative 2/3. 18 divided by 3 is 6. And I guess that was it. Yeah, so the slope here is negative 2/3. And again, I'll think of that as negative 2 all over 3. So go down 2 and then write 3. And then the y-intercept is at 0, 6. Okay, so you just take the 6, and that's the second position in your ordered pair. All right, so let's go ahead and graph it. You want to start at the y-intercept, 0, 6. So 1, 2, 3, 4, 5, 6 is right about here. And then you go down 2 and then write 3. So 1, 2, and then 1, 2, 3. Connect the dots, and it's good to go. What else? Yeah, the other method you could try then, if you don't want to do that, is using the XY intercepts. This is usually what I would do. So let's look at 71 this time. And we have 8x minus 2y plus 12 is equal to 0. Get an x-intercept going and your y-intercept going. So again, for the x-intercept, you're letting y equal 0. So you'll have 8x minus 2 times 0 is 0, and then plus 12 equals 0. And it looks like, did I screw that up? No, I'm good. 8x is negative 12, and then x is negative 12/8. Simplify that, so divide top and bottom by 4. So negative 3/2. Over here, the y-intercept, you let x equal 0, and then you'll have negative 2y plus 12 is 0, and that'll work out nice. Negative 2y is negative 12, and so y is just 6. So you basically have your 2 points, and you come over here and graph them. 2, 3, 4. I guess I gotta go up to 6. 3, 2, 3, 4. Negative 3/2, negative 1.5 is right there. 6, 1, 2, 3, 4, 5, 6 is right here. Connect your dots, and it's good to go. Okay? So that pretty much does this for linear functions and slope. Okay?